D, the point at which the box transitions from ramp to floor, so D. E, the point just before the box touches the wall, and so I'm going to change that, make that E, and then F is just before box touches wall. Make sure I've read that. It's gotten better. Also, a lot more complicated as I go. Because my thinking is, oh, well, they've seen the old test, they can do the simple stuff, let's just make it more complicated. Let's see what they can really do. All right, I do need to define, is B on the level floor at time B and D? Is it on the level floor or is it on the ramp? Because all I say is it's the transition. So I'm going to make them part of the level floor. So B and D. Sort of symbolize it's part of the level floor. And E was just before the box touches the wall, or F now. All right, so we have our classics. I think at that point, acceleration was first, and now I have acceleration last. That's another change I've made. So why don't we start out with position, plus 0 or minus. And we have to account for everything here. So time A is when the whole thing begins, and then between A and B, and then B, and then between B and C, and then C, and then between C and D, D, between D and E, E, and between E and F, and then F. So that accounts for all the times. A, B, C, D, and E, and F are times, are specific times, and then the stuff in parentheses in between is identifying what's happening between A and B, B and C, and so on. So first off, and I think at that point I called them positions instead of times. Officially they should be times instead of positions. Again, another change I've made. All right, so at what time is it at the origin?
B.
Okay. Anywhere up? Any other time?
D.
I think you said D.
Yeah, I did.
So those are the points when it is possible for it to go from positive to negative or negative to positive. Now, if you've looked at some of the solutions for acceleration, it doesn't always transition to the, at 0, it could also jump back to what it was before. But in this particular case, it said to the right was positive. So anything to the right is positive, and well, that happens after B and before D. So that's when the box is to the right of it. So in other words, that's when it's to the right. And then it's negative the other times. Because it starts out on the negative side of the origin, and it ends up on the negative side of the origin. Questions on this before we talk about displacement?
How would you show that with the annotation with the bracket and
The bracket notation would be, let's see, I'll just put it over here. So this is between B and D, not including B and D. So parentheses B, D.
and then the other one from A to D?
Well, the 0 would be B, comma D. There's no parentheses or brackets because you're talking about these specific moments. And then the last one, A is included. B is not. So that takes care of this chunk right here. And then the chunk down there, D through F.
Thank you.
From this right here, if you have just a single letter, it's sort of a bracket there, and so if you imagine, so A to B, this section right here, You got the single letter, so it's sort of a bracket there and then parenthesis over here. And this is just B, so some people will, instead of just writing B like that, they'll write B with the square bracket, which is also acceptable. If you do B without the square bracket, then what you're saying is everywhere from B to B, but not including B. So I think I generally give credit for this one, but really this means nothing. All right, other questions up to here? All right, velocity. I had the red marker, there it is. Oh, not velocity, displacement. Displacement. Plus 0 minus. And again, I think it's easiest if we sort of first identify where is it 0? Where is displacement 0?
Where it starts A and where it stops at.
A.
A and E.
A and E. And again, if you're looking at the old test, not E on the old test because that was a mistake. So it's 0 at the starting point, and then it's 0 when it gets back to the starting point. And again, this is overall displacement by default. So I've got my zeros there, so what about in between them, positive or negative?
Positive.
Because I'm on the plus side of that, so it is indeed positive here. And then, if we've done that right, negative's got to be everything else. So we could write it using the parenthesis bracket notation. So between A and E, and this would be A comma E, and this is E through F. Now, the definite advantage of doing this is that you know you've taken into account all the parts. This one, you have to sort of visualize basically that, just make sure that you cover everything. You have A, then between A and E, E, then from E through F. All right, questions on displacement? All right, velocity. Where's velocity 0?
Is it C? Cause it's the turning point.
Which letter?
C? Cause it's the turning point.
Sorry, you said B?
C.
C. Okay, yes, yes it is. Sorry, there's certain letters when people
No,
say
you're
them,
fine.
I don't distinguish, I apologize. Yeah, C is the point where it turns around.
And at F, does it stop?
No, F is just before it touches the wall.
Okay.
And so what determines the plus or minus of velocity? Or just the direction? You said direction or speed?
Yeah.
Okay, just for the plus or minus, it's just the direction, the speed is the other piece of velocity, but all we care about is direction at the moment. So when I'm moving to the right, plus, moving to the left, negative, and I start out moving to the right. After C, I've turned around, I'm going the other direction. And so using the notation, so that's from A up to C, so A to C, parenthesis there. This is just C, and then V, C through F. Any questions about velocity? All right, so now acceleration, which was originally, I think, your question. a couple ways of looking at acceleration. The way that always works is if you think about the total force acting on it, that the acceleration will always be in the direction of the net force, because F equals ma, Newton's second law. I have an equation here with only two vector quantities in it. They have to be in the same direction. So as it's sliding from, there's no friction in this particular problem, so as it's sliding from here to here, what are the forces acting on the box?
Weight down?
Yep,
Normal force.
I hope so, otherwise it's in free fall. Anything else?
I mean, if it's sliding, there has to be an other, right?
Newton's third law. And how it got moving, we don't care. We come into the problem when it's already moving. And so it needs a force in order to stop it, or net force in order to change that. But once it's moving, it's just gonna keep moving unless there's something else that says otherwise.
Is it the wall?
You said it's the wall?
The wall?
The wall, oh, when it gets to the wall, well, actually it never touches the wall within this problem.
Okay.
If it hit the wall, then the wall's gonna be exerting a force that way on it. And so that would definitely cause it to change its velocity.
Friction?
Pardon?
Is it friction?
No friction.
Oh.
It is a frictionless problem. Back in those simple days, 8 years, no, wow, almost a little over 8 years ago. Simpler times. So there are only two forces acting on it at this point. Now, some students really want there to be a reason it's moving. Some particles do come into existence already moving. So, basically from our point of view, there is a non-zero probability, not a large one, but there's a non-zero probability that this box came into existence already moving that way. It didn't necessarily have to start out at rest relative to us. So how it got to its position at point A moving that way is completely irrelevant to the problem. Because motion has no memory. We don't care about what happened before.
So if it's frictionless, there's nothing slowing it down, there's
Right.
nothing speeding it up, so acceleration is zero the entire time?
Not the entire time, because once it gets to the ramp, it will start slowing down.
Okay.
But it is zero until, let's see, I guess at point B is the last point, it's on this.
And so it speeds up as it's coming down also?
Say it again?
Does it speed up when it's coming down the ramp?
Yes, it will.
Okay.
So as it's going up the ramp, slows down. Not because of friction, but because the net force is down the ramp. Because the weight is acting down, so as it's going up the ramp, the weight is acting straight down because weight acts down. Normal force acts perpendicular to the surface because normal force acts perpendicular, that's what normal means. And if you add these two forces together, that they don't cancel each other out. That there is a net force acting down the ramp. So, as it's sliding up the ramp, the net force is down the ramp, which slows it down. At C, there still has to be a net force on it, otherwise it would just, once it stops at point C, they would just stay there, so there's gotta be something to cause it to change that. And as it comes back down, it's speeding up. So again, the net force is down the ramp. The forces acting on it do not change. Once it transitions to the ramp, the forces acting on it don't change. And so acceleration is negative till it gets off the ramp again, which is at time D.
In the answer key, you said that it wasn't ever positive.
Right, so at D, or once it gets to time D, it's now on the flat surface again.
So it's not accelerating between C and D?
It is.
No, it's-
Between C and D, that's this right here.
but it's a negative? It wouldn't be positive?
It's going in a negative direction,
Oh, okay.
because to the right would be positive.
Okay.
Between C and D, is it speeding up or slowing down?
It's speeding up.
Yeah. So if it's speeding up, acceleration and velocity have the same sign. So velocity's negative, acceleration's negative.
See, it's confusing because it's slowing down from B to C, but it's going in the positive direction.
Right.
So if you're going off direction, you would think B and C would be positive. Because the direction's positive.
The velocity's positive because it's going positive there. But because it's slowing down between B and C, velocity's positive, acceleration's negative. You're slowing down. I feel like I didn't address what you just said.
No, I'm just so confused.
You work from.
Like, I get your reasoning, like, when she said direction, it's going negative direction, so that makes sense. But if we're going based off direction, B and C is positive. But I don't understand, I mean, I understand why it's negative.
Is it slowing down?
Yeah.
Let's look at this. Well, just because it's negative doesn't mean it's slowing down. Case in point here. All right, let's look at it from a slightly different point of view. At A, it's moving to the right at some speed. I don't know what it is, but I'm just going to make up a number. I know it's a positive velocity, so 10 meters per second. At B, it's still going 10 meters per second because there's nothing to stop it from doing that. At C, it's going 0. At D, it's going to slide back down. If there's no friction, the velocity will now be negative 10 meters per second because it's going in the negative direction. At E, negative 10 meters per second. At F, negative 10 meters per second. If the problem continued, as I did in later years, it would hit the wall and it would stop at the wall and then either bounce back or stay stopped. Acceleration, change in velocity over change in time. Again, if I have an equation with only with a vector on each side of the equal sign, they have to be the same direction. So acceleration has to be the exact same sign as change in velocity. So from here to here, what's my change in velocity? When I go from 10 to 10, what is the change?
0.
So my change in velocity, 0 meters per second. And so my acceleration is 0 in that region. From here to here, from 10 to 0, what's my change?
Negative.
So my acceleration is negative. From 0 to negative 10, what's my change? Change is always final minus initial.
Negative 10?
It's negative 10. So my acceleration is negative through that whole
Okay,
section.
that makes more sense.
Okay.
Okay.
And then it's 0 again because it doesn't change. There's several ways of looking at it, and I try to present them all, which if you start mixing and matching, it can get really horrible. Some students that sort of will latch on to one way of looking at it, which works really well a lot of the time. If you're brave, you'll look at it several different ways and hopefully get the exact same answer. And if you don't, then that's when the torture starts.
So, unless it's like one of those problems where it's like the hockey puck and it gets hit between this point, acceleration shouldn't be positive.
Right. If I throw some friction into it,
Okay.
if I threw some friction in here,
Then after the friction, it would be,
it'd be 0 there. So it still starts at A. Let's say I have friction in here now. So everything is the same until it gets past time E, when it hits the friction. When it hits the friction's gonna slow it down. So if that's negative 10, it's gonna slow this down to, let's say, negative 5 by the time it hits the wall. What's my change, going from negative 10 to negative 5?
-5.
Positive 5.
Okay.
So if there's friction, it's positive.
after you,
During the friction?
after the friction.
If, when you say after the friction, I feel like there are two different things being said there.
We're saying, like, when would it be positive? It would be positive after you've passed the point of friction.
While you're going through the friction, the acceleration is positive.
So how would you write that on?
between E and F, it would be positive.
Yes.
If there was friction right there.
If there were friction right there, if I had, and assuming F, it's still, there's still friction there, then this would have. So let's assume E is the last point before friction. And so that means after E, so this would
Okay.
pop up to positive. Because it's going in the negative direction, it's hitting friction, friction acts opposite the direction of motion. So its velocity is negative, the friction is positive, and acceleration is positive.
So basically with that, since the speed is slowing down, so it would be, that would be a negative, along with it's going in a negative direction, the two would equal positive. Or,
I really hesitate to look at it that way,
okay,
because it's going in the negative direction and slowing down, acceleration is the opposite sign. It sounded like you were going for two negatives make a positive.
yeah.
That's fine.
Does that work? Always work? That's the part that I'm.
So is friction always positive, cause they're gonna, what is it called?
It's gonna change the acceleration.
No, they're going in opposite directions, cancel out. Is it positive cause they're gonna cancel out each other?
It depends on what you mean by they. What are you
Okay,
picturing
so
canceling
like-
out?
The acceleration before and the acceleration after the friction.
No, the directions. So if you're going this way and friction's going this way, they cancel each other out and it's positive.
Yeah, the reason I hesitate to say canceling out, and I haven't forgotten your comment, Emily, I want to get back to it. Is